And what interpolation means is we're going to use our line between our all of our known data points to come up with some information. So let's say this is 2. Let's say this point right here is 5, and I want to know what the y value is on my line at 5. I don't know exactly what it is from the data they gave me, but I can use my line of best fit to find out what it is. And 5 is within my data here. Let's say this is 10. Okay? Let's say this is at 10. Let's say I want to know some information at this point. I wasn't given that exact data point, but I can use my line to find out what y is when, say, x is 7. And 5 and 7 are within the data range, aren't they? The points they gave us. That's interpolation. Inside, interpret, inside. That's how I remember. Let's talk about extrapolation. Let's say I'm going to use my line to find out what y is when x is 13. That is outside. It's extra. It's extrapolation. Outside. Take that out of your ears, please. This is extrapolation, okay? So this is outside my data set. That's the only difference between the two. When you're trying to find something within your data set or something outside of your data set. So if you want to do like a little thingy here, say this would be using interpolation. It's inside the range of my data points. Anything from here on out is extrapolation. And we're going to practice that today a little bit. All on the calculator. Are you going to have to know it for the final? I think so. I haven't seen the final yet, so I gotta go ask them about that. All right, the other thing we're going to do is the zero of a function. It doesn't have anything really to do with linear and or interpolation, extrapolation, a little bit. All it is what x makes y 0. Okay? You set the function equal to 0 and solve for x. That's all you do. We're going to look at that. Okay, when your output gets to 0, what was your input at that point? We should probably close this. Okay, I am a direction follower. I think I told you that. So, don't you dare! I'm watching. I will. It's like they're let loose all of a sudden. All right. So these are the directions to do this on the 84, if you need it. We're going to go through it real quick, but these are here. All right. And what I gave you, Liam, was the directions for the Inspire. Okay. So I used to have that on there. So the first thing we're going to do is this one right here. Find an equation that models the number of hikers completing the Appalachian Trail, something I want to do, it's my bucket list, as a function of the number of years since 1996. So we have to figure out what the inputs and the outputs are. So the number of hikers as a function of, does the number of hikers depend on the year, or does the year depend on the number of hikers? Hikers depends on the year, right? So hikers is your dependent variable. The hikers are your y, or your output. Okay? Now, I am not going to plug 1996 into my calculator. The calculator reads that as 1,996, and it's going to be not a good graph to look at. So where are we starting? What year are we starting at? So that's going to be where my x is 0. So over here, the year is my input, and 1996 is 0. What's 1998? 2, 3, and 4. That's what I'm going to use for x, okay? All right, now we've determined that. Now we can get the calculator to give us an equation. So it says figure out the inputs and outputs, which we did. Push, you're going to turn it on. You're going to push the stat button, which is right here. Stat. And then it says you need edit. So you push enter. And you might have lists in your thing. Do you have numbers here? Okay. To get rid of those, Are you everybody here? You're really going to have to pay attention to stay with me, because I don't want to repeat multiple times. Did you push stat and enter? Yes or no, ladies? Okay. To clear these lists, you arrow up so that you're highlighted on L1. And then you push clear, right here. And then you arrow down and your list will go away. Did you do it?
Yeah.
And then arrow over and do the other list. Highlight on L2, push clear, and arrow down, and your list will go away. Yes, yes? Are they clear now? Okay. We're going to enter our data. Did you arrow down then after you hit clear? Okay, you're going to put your inputs into L1. That means you're going to put your X's into L1 and your Y's into L2. So go ahead and do that. We're going to use 0, 2, 3, and 4. Then we're going to arrow over, and you're going to put your outputs, your Y values. Okay, now before you do anything, you should always make sure you have the same number here as the same number here. Because if you're off by one, the calculator isn't going to like it. So you should have 0, 2, 3, 4, and you should have these numbers. Are you good? What happened? It's okay. It can show up down there. Arrow down one more or arrow up. It doesn't matter. As long as you have 4 and 4. Do you have 4 and 4? Are they not even going in your list, Garrett?
No. You hit enter after you type them.
Okay. It's all right. I'm going to get everybody there. Are you there? Shouldn't take too long. Okay. Now, the calculator, you can tell it to graph. This is a scatter plot. You can tell it to do that. We can do that. I just don't want to confuse you right now with that. I want to get my equation. The line of best fit through those points. So, it says here, is everybody with me?
Yeah.
Okay, you push stat, go back to the stat button, push stat, then you go over to calculate, so you're going to arrow over to calculate, and then it says number 4, and that's what you want, number 4. You should have this right here, yes?
Yes.
Number 4, it says right on your directions, number 4. Okay, are you here now? Now, this is saying, okay, is your X list in L1? Yes, it is. Is your Y list in L2? Yes, it is. We could change that if we wanted to. This, I have no idea what that means. This, we want it to calculate the line of best fit. So you're going to arrow down to calculate. This was a little different than mine, so that's why I don't have that on the directions. And you push enter. Oh, would you look at that? Look at what this is. This is a linear equation. Y equals ax plus b. They use a instead of m. I don't know why. They just do. Okay? And here's your a, and here's your b, so you can write your equation. So, we're going to go here. It says a is your slope and b is your y-intercept. Substitute a and b into y equals ax plus b to write the equation. Usually rounding to 2 decimal places is acceptable, so let's round to 2. So my equation is going to look like this. Y equals 56.26x plus 369.17. And there's my equation. Isn't that nifty? You get really quick at this. You can do it in like 30 seconds once you start practicing. All right, that's the equation of the line of best fit. Yeah, so it starts on the y-axis at 369, and every year it goes up by 56.26, an average of 56.26 is what it's saying. So, use your equation to approximate the number of hikers who completed the entire trail in 1997. Wait a minute, didn't we do 1997?
No.
No. But in 1997, what would my x equal? 1. It's 1 year after 96. X equals 1. So I'm going to use my equation. And I'm going to plug in 1 for x. And do the math right on your calculator. If you want to clear out of this, you can just push clear. And then do that math for that equation. Can you see it? So go on your calculator and figure out what this would be right here. Okay, that's all right. I rounded up. Can you have a point of a person?
Yeah.
No, because we're talking about hikers, aren't we? So we're not going to make it 426 because we don't have a whole person. So we got to bring it down to 425. So what this means is in 1997, 425 hikers completed. We'll just put the completed. Yeah. Okay, I have a question. Hey, how many people think this is interpolation or extrapolation? Who thinks it's interpolation? Who thinks it's extrapolation? Who really doesn't know? Okay. Well, let's think about this. We're talking about 1997. Is that within our data range? Yeah, it's right here. So because of that, it's interpolation. It's within our data range. Within our data range right there. That's where 1997 is. Okay? All right, turn it over. Let's do another one. So, the table shows the median floor area of a new single-family house in the U.S. during the period 1995 to 99. Our table is exactly within this. So that means, does the square footage depend on the year? It does, doesn't it? So that means this is going to be my Y, my output, and that's going to be my X. But I'm going to use 0, 1, 2, 3, and 4 instead of those year numbers. First thing I have to do is find an equation that models the floor area. Well, I'm going to have the calculator do that. So you're going to do it again on your calculator. First step, go to the Stat button. You have to edit your lists. So you're going to push Enter for Edit. Wait a minute, don't work too hard because my X values, oh, they're not quite the same, are they? I have to change both. So I've got to clear the lists. And then you're going to enter your new data. You can always use the delete button if you need to, if you make a mistake. So this is what you should have gotten. Y equals 26.6x plus 1921.4. Now I got that because it looks like this on my calculator. This is my slope and this is my y-intercept. Okay? You guys need a refresher how to do that? You push Stat, you go over to Calc. So you push Stat, go over to Calculate, and you want this linear regression here, AX plus B. You want the linear regression. So you push 4. And then you just go down to Calculate and push Enter. Okay? All right, let's talk about this. Write this down. We're going to do another one, so you'll get another chance. This is your equation. Predict the median floor area of a single-family house in 2000 and 2001. Oh, wait a minute. 2000 is outside of my data range. So we're actually going to do what here? Extrapolate. We're extrapolating. So that means my x value is 5 and my y, and then the next one is 6 for 2001. 5 and 6. So x equals 5 for the year 2000 and x equals 6 for the year 2001.
Isn't 2000 already on?
That's the square footage. This is my year. Okay? So I'm going to plug in 5 to my equation. You can just jump right in and do it on the calculator if you want. You're going to plug in 5 and you're going to plug in 6. So for the sake of time, I'm just going to tell you what the answer is. For the year 2000, it is, I don't have it, hold on, let me see. 2,054.4 square feet. And then, of course, you plug 6 into your equation, and then you would get, for 2001, it was 2,081 square feet. Okay? Let's do one more. Before I do that, the FCC issued during the period of September 2004 to January 2005. Predict the month and year in which the number of new general class amateur licenses issued reaches 50. Well, let's take a look and determine our input and output. Look at this. It goes from month to month, doesn't it? September to October to November to December to January. So we're going to have our input be, this is year 0, or month 0, month 1, month 2, month 3, and month 4. And then our output is the licenses. That's my Y. Notice what's happening to the licenses as each month goes. What's happening to them? So that means I should have a what kind of slope? Negative. See how smart you're getting? Yes, negative. Okay. Whip these numbers into your calculator and try and come up with the equation real quick. Take a time here. Did everybody get this?
Yes.
Yes, and it's a negative slope. Fantastic. It should be. It's going down. Okay? So, it says here, all right, so what month and year does it reach 50? So it keeps going down. I want to know what x is when y equals 50. My licenses are 50. I need to find x. So, I'm going to take and plug 50 in for my y, because licenses is my output, my y. So that's what I'm going to do. And I'm going to just do the math. Oh, look, you get a little algebra equation to solve. And find out what x would be when y is 50. Subtract 197. I'm going to extend my list here. 6, 7, 8. Because I found out it was where x is 8. So that makes it February, March, April, May, 2005. Right? So that means in May 2005, that's when the licenses got as low as 50. What? 0 of the function. Now remember on the other side, I told you the 0 of the function is when y equals 0. So I need to find out when this got all the way down to 0. When y equals 0. So all you do is you take your function and you plug in 0 for y. Plug in 0 for y and solve. So this means in July 2005, they reached 0 licenses issued, however you want to write it. In July 2005, they reached 0 licenses issued. Now, my goal is obviously